Hey guys, I'm going to be introducing the comprehensive example we're going to be doing for dead and live load case. So the objective for the videos to come are going to be finding permanent and imposed actions on the slab, permanent imposed actions on joist, permanent imposed actions in girder. We're then going to be finding the maximum bending moment and shear in the girder for permanent imposed actions respectively, assuming the beam is simply supported, and then we're going to be finding permanent and imposed actions in edge column C1 with and without live load reduction. Okay, so here's our problem. We have a plan which looks like this. We have columns over here. We have a floor slab. We have B1, which are known as joists. We have B2, which is a girder. And we have B3 along that edge, that edge, that edge, and that edge, which are all exterior girders. Okay, so we have an interior girder B2, an exterior girder B3, and joists B1 with a slab above all this. And there's columns with 900mm diameters at these edges, and this is column C1, the edge column we're eventually going to be finding. So it's a 10-story structure. It's an office building. The height from the top of the slab to the top of the slab above is 4 meters for the roof and floors. For the roof and floors, there is a depth of 130 mils for the concrete. The density of reinforced concrete is given as 2,500 kilograms per meter cubed, and we're given the gravity as 9.8 meters per second squared. So we're also given sections of each part. So section AA through B2. So section AA through B2. The slab depth, as we said, so you can see for each section, section AABBCC, AABBCC, the depth of the slab is 130 everywhere, because we said that the depth of the slab is 130 millimeters. Yep. So just for AA, the area of our beam, it's 1060 by 400 mils. For section BB, so section AA would be through the girder, the interior girder B2. So if I write that in blue, so that in other words is beam 2. Section BB is through beam 1. So that would be the joist. So that's 300 by 400 millimeters. And section CC through B3. So this is for B3. We're given as 530, and this is also 400 by 130. Okay, so there's the main thing I want you to realize from this problem. We're going to be going through the process in the next couple of videos coming up to solve all this stuff. Just from the outset, I want you to realize that based on this plan and all these sections, we have sort of an issue like this. We have a problem like this we spoke about in the previous videos, okay? We have the girder and the joists in the same plane, not stacked on top of each other, okay? So we know that when we have this case, we might have an issue of a two-way or one-way slab, okay? So we're going to have to find that out in the video, in the upcoming videos, but I just want you to realize at this point that our girders and joists are in the same plane. They're not stacked up on each other, so the load path isn't as obvious as it would be if they were stacked up on each other. Okay, so that's just what I want you to realize from this video. So just to show you, it's not like this. It's not stacked up. They're all in the same plane based on these sections. Okay, so that's just the first realization I want you to be aware of. Anyway guys, this is just a very brief introduction to the problem. The first thing we're going to be doing in the next video is finding the permanent and imposed actions on the slab in KPA. So we'll see you guys in the next video.
Cut study time with concise video summaries by top students. Visit spoonfeedme.com to view more free videos in this course and hundreds of others.